Okay, so now we're going to go over some examples of work being done. We're going to look at some word problems. So here's our first one. It says, starting from rest, Jeff drives his 2,000 kilogram car down a 10-meter hill. At the bottom of the hill, Jeff's car has a speed of 10 meters per second. Was any work done on the car? If so, was the work positive or negative? So the first thing we can do is look through the word problem itself and pick out good information. So here we have 2,000 kilogram. That means our mass is 2,000 kilograms. We can tell because of the unit, kilograms is for mass. And he drives down a 10-meter hill. So that means this hill over here is 10 meters. So that means originally his height to begin with is 10 meters, and at the end his final height is going to be 0 meters because he's all the way down at the bottom of the hill. So it says at the bottom of the hill Jeff's car has a speed of 10 meters per second. So down here he's got a speed V final, and V final is 10 meters per second. It also says starting from rest. So that means up here his initial velocity, VI, is 0 meters per second. That's what it means to start at rest. It means the initial velocity, the starting velocity, starting speed, is 0 meters per second. And we want to find out, was there any work done? So, step one, what we want to do is find the mechanical energy at the top, or the initial mechanical energy. Remember that mechanical energy is potential energy plus kinetic energy. So at the top, the initial mechanical energy is the potential energy, which is mg h initial, the first height, plus, and the kinetic energy is 1/2 mass times the initial speed squared. So that's just plugging in the formula. Potential energy is mgh, kinetic energy is 1/2 mv squared. So that means the mechanical energy, now we can plug in our numbers. The mass is 2,000 kilograms. G is always going to be 10 meters per second squared. And the initial height we have up here is 10 plus 1/2. Mass is 2,000. And the speed is 0 squared. And that's nice because 0 squared is going to be 0. If he's at rest to start, there's no kinetic energy, so this part is all 0. This part is all 0. So the initial mechanical energy then is just 2,000 times 10 times 10. That's 200,000. And our units are joules for mechanical energy. So that's our initial mechanical energy. We just wrote out the formula for mechanical energy, then we changed potential energy into its formula, kinetic energy into its formula, and we plugged in our numbers. This part is all 0, and this part gives us 200,000 joules. So I'm going to clean this up a little bit so that we have some room, but of course you can always rewind this video to see all that work. Let's move this up here. Alright, so now we're going to do the same thing, but for the final mechanical energy. So we're going to find the mechanical energy at the end, the final mechanical energy. Again, mechanical energy final is going to be the final potential energy plus the final kinetic energy, which means potential energy is mgh, final, plus kinetic energy is 1/2 mv final squared. Now we plug in our numbers. Mass is 2,000. G is 10 as always. And the final height we have up here says 0. That's great because that's all going to be 0 then. You multiply it together. Plus 1/2 times the mass, 2,000, times V final squared. That's 10 squared. And if you plug that into your calculator, again, 2,000 times 10 times 0, that's all 0, plus 1/2 times 2,000 times 10 squared. It's the same thing as 1,000 times 10 squared, or 100,000. And you can just do that on your calculator. The units again are joules. So we found that the final mechanical energy is 100,000 joules. Alright, so again I'm going to just clean this up a little bit. You can rewind or pause if you didn't get all that. Move this up here. Alright, and now third step is to find the work. And the work is the change in mechanical energy. So it's the final mechanical energy minus the initial kinetic energy. So now we can just plug in the numbers that we got. The final mechanical energy was 100,000 minus the initial mechanical energy was 200,000. Whoops. 200,000. So we end up with work is negative 100,000 joules. That's the unit for work because that's the unit for energy. So 100,000 minus 200,000, you get negative 100,000 joules. So there was work done, and it was negative. So I'll write that over here. Yes, work was done. And it was negative work. Remember that negative work means energy was taken away. And in this case, it was taken away by friction. So friction caused some negative work.